Welcome viewers, in this video we will see the solved problem based on the coupled circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic coupled circuit solved problem 8. Let us consider this coupled circuit. The two inductors are available and one resistor, capacitor and one more resistor available. In the closed circuit shown in the diagram, find the voltage across the 5 ohm resistor. Our aim is to find the voltage across this 5 ohm resistor. The voltage applied is 75 voltage. 75 voltage with 0 degree. This is plus minus. Right. So first we will find the mutual inductance. This is coming under coupled circuit. Two inductors are available coupled together. So first we will find the mutual reactance between these two inductors. That is Xm equal to K into X1, X2. This K value is given as 0.8. Mutual coupling coefficient between these two coils is given as 0.8. So 0.8 into square root of X1 value is 5, X2 value is 10. So 5 into 10, 50. Square root of 50. After simplification we got 5.66 ohm. The mutual reactance between these two inductors are 5.66 ohm. Now with this value we can redraw the circuit. We can include this mutual reactance in the circuit so that we can redraw the circuit. So the conductively coupled equivalent circuit is drawn as below. So this 5.66 is now connected. It is commonly available between 5 Henry inductance and 10 Henry inductance. This is commonly available. In order to compensate, it is subtracted with minus J 5.66. Here also minus J 5.66. So this 5.66 is nothing but mutual inductance between these two inductors. So it is connected commonly. This is called a coupled circuit. Coupling between the two inductance. So it is added. In order to compensate, it is subtracted on both the sides. Now it is a redrawn. Now the circuit is redrawn with the conductively coupled equivalent circuit. Conductively coupled mutual reactance. Right. Now our aim is to find the voltage across this 5 ohm resistor. So V equal to I into R. So we need to find the I value. Into R is 5 ohm. So I will go for the mesh analysis. KVL. We'll take this is the loop 1 with the current I1. This is loop 2 with the current I2. So I2 into 5 is nothing but voltage. Voltage drop across 5 ohm resistor. Now our aim is to find the value of I2. Now by using the inspection, by use the matrix method, we'll go for the matrix method, mesh analysis. So this is the impedance matrix, current matrix, voltage matrix. V equal to I into R or Z. So the I is I1 and I2. So this is loop 1. This is loop 2. In loop 1 we have 75 voltage. 75 with 0 degree voltage source is available. In loop 2 the voltage source is not available, 0. So the current matrix I1, I2, voltage matrix 75, 0 degree and 0. Now we'll see the impedance matrix. So this is nothing but called Z11, Z12, Z21, Z22. Z11 is nothing but all the resistance and reactance available in the first loop. Or Z22 is available in the second loop. Z12, Z21 is nothing but commonly available. Right? So first we will find this. So what are the elements available? J5 minus J5.66 plus J5.66 plus 3 minus J4. So all these elements are added. Inductor, capacitor and the resistor all are added together. So this is called a impedance. Now similarly this Z22, all the elements available in the second loop is added together. Minus J5.66, J10, 5 minus J4 plus 3 plus 5.66 all are added together. Z11 the impedance available in the loop 1. Z22 impedance available in the second loop. Z12 and Z2 is commonly available. See this in this is the first loop, this is the second loop. So these elements are available commonly between loop 1 and loop 2. So that is written as 5.66 plus 3 minus J4. It's negative. These two. Other than diagonal, other elements are negative. So you will put minus. Now we'll go for the further simplification. So by adding this, we'll got 3 plus j. Similarly, this one minus 3 minus j 1.66. Both are same. By simplifying this, we got 8 plus j6. Then current matrix and voltage matrix. Right. Then how will you find the current? Our aim is to find the voltage across 5 ohm. For that, we need I2. I2 is delta 2 divided by delta. What is the delta value? So this determinant of this matrix is called delta. Delta 2 is the second column is replaced by the voltage matrix. It is delta 2. If the first column is replaced by voltage matrix is delta 1. This is delta 2. Right? So the determinant of this matrix is delta. We have to replace the second column with voltage. We need to find the again determinant, that is delta 2. From delta 2 and delta we can easily find the I2 value. Now we'll see how to find the delta and delta 2. So this is the determinant. This is the matrix delta. We need to find the determinant of this matrix, that is called delta value. So we have to multiply these two values. 3 plus j into 3 plus j into 8 plus j6 minus these two values. We have to multiply these two values. Minus of minus 3 minus j 1.66 minus 3 minus j 1.6. Both the values are equal. So the determinant is these two elements are multiplied minus these two elements are multiplied. Now we'll go for the simplification. 3 into 8, 24. 3 into j6, 18j. J into 8 is 8j. J into j6 is j square, 6j square. Minus, right? There minus is there. So minus is available outside. Now we'll multiply this. Minus 3 into minus 3 is 9. Minus 3 into minus j 1.6 is 4.98j. Similarly, we have to multiply these two. Then plus 4.98j. Then these two. 2.8j square. Now we'll go for the further simplification. 24 plus this 26j. You have to add these two. 26j plus 6. J square is minus 1. We know that j square value is minus 1. Minus of 9 plus these two we can add. 4.98j plus 4.98j. That is 9.96j. Similarly, j square is minus 1. Now we'll go for further simplification. So 24 plus 26j, 6 into minus 1 is minus 6. Minus of 9 plus 9.96j. So here minus 2.8. We go for further. So 24 minus 6, 18 plus 26j minus of 9 minus 2.8 is 6.2 plus 9.96j. Now we'll multiply this negative inside. So 18 plus 26j minus 6.2 minus 9.96j. Now we can add this. 18 minus 6.2, 11.8. 26j minus 9.96j, j 16.04. So this is called a rectangular form. What we need is the polar form. So that we can go for easily divide. For division and multiplication we need polar form. Addition and subtraction, this rectangular form is enough. So we need to convert into polar form. That is magnitude and angle is the polar form. Real term, imaginary term is the rectangular form. How to find the magnitude? Square root of this square, 11.8 square plus 16.04 square. For that is nothing but square root of a square plus b square. Then how will you find the angle tan inverse b by a? So this is b, this is a. B by a, 16.04 divided by 11.8. So square root of a square plus b square tan inverse b by a is the formula. So after simplification we got 19.9. The magnitude is 19.9. Angle is 53.7 degree. Now we got this value. Next we need to find the delta 2. I2 is equal to delta 2 divided by delta. So we need to find the delta 2. What we need to do, the second column is replaced by voltage matrix, that is delta 2. Delta 1 is not needed. What we need is only I2, so we are calculating only delta 2. Now we have to multiply these two. 3 plus j into 0 minus of 75 into this term. 75 into minus 3 minus j 1.6. Now this term is totally 0. This minus, here also minus available. So we will take outside, so it become plus. Plus 75 into 3 plus j 1.66. Now multiply inside. 75 into 3, 225. Plus 75 into 1.66 j is j 124.5. So how to find the polar form? This is rectangular form. We will go for polar form. Square root of a square plus b square. A is 225, b is 124.5. So this 225 square is 50,625. 124.5 square is 15,500.25. Right. So while adding what we got, 66,125.25. The square root is 257.3. Similarly, we need to find the angle tan inverse b by a, 124.5 divided by 225. That is value is 28.96. So the delta 2 value is 257.3 angle 28.96. Now we got the delta 2 as well as delta value, so that we can find I2 value. Now we'll see how to find the I2 value. So I2 equal to delta 2 divided by delta. Delta 2 is 257.3 angle 28.96. Delta value is 19.9 angle 53.7. So how to simplify? We have to divide these 12 magnitudes. So normal division. 257.3 divided by 19.9, that is 12.93. Then angle, how to do that? If it is division mean we have to subtract the angle. 28.96 minus 57.3. If it is multiplication mean we have to add the angle. Division mean we have to subtract. So what we got? Minus 24.7 degree. So 12.93 angle 24.7 degree amperes. But what we need is voltage across the 5 ohm resistor. 5 into I2. V equal to I into R. I is I2, R value is 5. So substitute this I2 value. 12.93 angle minus 24.7. So angle is written as it is. 5 into 12.93 is 64.7. So this is the final value. 64.7 magnitude angle 24.7 degree voltage. So in this problem, coupled circuit, we solved the coupled circuit. Finally, we calculated the voltage across the 5 ohm resistor. The important thing is two inductors available. We calculated the mutual reactance. Based on that, the circuit is redrawn. The mutual reactance is connected commonly at the center. So in order to compensate, that is subtracted from the two inductors. Then we'll go for the simplification using the Kirchhoff's voltage law, using the mesh analysis. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.